transform a source, and we show the current source will be transformed to voltage source, and vice versa. Now, how we are going to do it? When we have voltage source series with element since it is electric circuit 1, mostly resistor, will transform it to current source which will be in parallel to the element now to the element. How? Let's say, for example, I have this voltage source Vs, which is in series with resistors R. So in this, since it's the voltage source is in series with the resistors R, is going to be transformed to a current source, which will be in parallel with the resistor. I have R is going to be Is. So how determine the value of Is? The value of Is is going to determine by Ohm's law, Vs divided by R. So if I have a current source, a voltage source which is in series with a resistor, I can transform it to a current source parallel with the resistor, the same resistor. The current source, it will have currents will have currents. The currents Is equal Vs by R is vice versa. If I have a current source which is in series, in parallel with the resistor, I can transform it to a voltage source with series to the resistor as it is. How? Now we have to pay attention on something. What the sign? So the sign of this one, the voltage is plus minus, mean that the currents will be in this direction, because we saw in the introduction that this one, the arrow mean that the positive terminal, this one is the negative terminal. Mean that if my voltage source is like this one, in this orientation, like this one, mean that the current source will be oriented in this direction to follow the polarity parallel with this resistor. We'll see in this example. That is the source of transformation, either dependent or independent. All will be the same. We can be transformating. Now, in this example, let's see in this example. If we see that example, we have, and we have to also know that when we did the source of transformation, by the end you can use any method that we learned before. You can use it, either current source, current division, voltage division, any. Let's say, for example, here, if we realize, we'll see that this one is a current source which is in parallel with a voltage with a resistor, mean that I can transform it to voltage source which will be in series with the resistor. If we see this one again, this one is a voltage source which is in series with a resistor. Voltage source, here it was current source, here is going to be voltage source in series with the resistor, means I can transform it to current source parallel with the resistor. So here I will have the resistor, this one, I will have this voltage, the current source is going to be transformed to a voltage source, means that I will have this voltage source minus plus, because the direction of the current, here is the positive, here is the negative. I will have plus minus series with the 4 resistor. 4, I have 2 resistor here. Now if I see here again, I have the 8 resistor with V0 I'm looking for. If we check here, I have the voltage source and the current source. Now, the voltage source and the current source, how to determine? It will be in series with the voltage current source. Direction of the current source is this one, because this one is a positive, this one is the negative, so it's going to be in this direction. Now, here is my 3. How to determine the current source? Is is V12 divided by 3 is going to be 4 ampere. How to determine the voltage source? Is going to be this resistor 4 multiplied by 3 with 12. Now I am here. I'm this case now. If we see this one and this one are what? In series. So since they are in series, I can make as one resistor to make 4 plus 2, which is equal 6. So I can make to be equal 6. This is 6 come from the 4 plus 2. Now, if we see this voltage, this resistor and this one are what? In series. They're in series, isn't it? No, they're in parallel. I can determine the equivalent, or I can use nodal analysis here to determine this one, to determine the V0, because I want to find V0. When I want to find V0, let's say for example I am here 12, 6. These 12 and 6, that is what? Voltage source and current source. I can determine. I can transform it. How? I will have a current source with parallel of the resistor. So the current source is going. I will have this direction, because plus minus. This 6 resistor is going to be in parallel. I will have the 8 resistor here. I will have 3 resistor here. I will have 4 ampere here. Here I will have the 6. I have the 8 for the V0. I have the 3. Now what will be the value here? I will have 12 volt divided by 6. I will have 2 here. Now 2 here. If we see, I'm going to, which method I will use to determine the V0? I need V0. Now I can go directly in one of the methods that we learned before, because if we want to transform again, it will come back here, because we have 4 multiplied by 3 is going to be 12. It's going to be 12 in series, so we come back here, 12 and 3 in series. If we take this one again, it's going to be this one. No. Mean that if we come in a case that you see that there is one method directly that we learned before in the previous video, that you can determine directly the equation, the voltage or the current that he told you, you can directly apply. In this case, I can apply what? KCL. We know KCL, we know all nodal analysis are almost the same. Here, this current is entering. This current is entering. So, since this current is entering, I will have 4 equal. This current will leave. This current will leave. This current will leave. This current is leaving again. So, I will have equal to, because 2 is leaving, plus I will have the voltage of this one, the voltage of this one, the voltage of this one. These are the same node, which is V0, because V0 is the voltage across the 8. I can make this node, all this node V0. So I will have plus V0 divided by 6, because the current flow in this, plus V0 divided by 8, plus V0 divided by 3. So in this case, you can easily determine the value of V0. We have to understand in this case this node, because if I have this one, I have this one, I have this one, mean that all this one are same node. All this one is same node. I can make this one is the same if I do this one. It's the same if I this one. I connect in the same node. And this one is the good one, because this one you are losing some wire. You are losing some wire with nonsense. So as an engineer, when we are going to design, we are designing with less wire. So instead of using this wire, and make this wire again, and we can join directly to them in this case. So, and we have to know that this one, if we this one is Vx, this one is the ground, and the Vx is the same as this one, because determine Vx is the potential of this one divided by 0 minus 0 minus 0. So Vx is the node potential as this node. Now you can easily determine the value of V0 in this equation. Now we'll do another example for better understanding. Now for example 3, if we see example 3, we have this one. If we see this one, we have this voltage source and the resistor. They are in series. I can easily determine, transform them to current source. I have this one current source, even it is dependent with a parallel resistor. I can easily convert it, transform them. So how? I will have this one. I will have a voltage source, a current source. I will have with the direction of this case, because positive here, negative here. The current source is going to be in parallel with the resistor. The resistor is 2. I'll have 2 here. Now, how to determine the value of the current? I have voltage divided by resistor. 6 divided by 6. I'll have 6 divided by 2 is going to be 3. So I'll have 3 ampere here. Now, if I come here, I have Vx with 2. Vx here. Now, here I have a current source. I have a parallel. I can convert it to voltage source series with this resistor. So I will have this resistor. I will have dependent again. Since it was a dependent current source, I will have a dependent voltage source, plus minus, because the direction of the current is this case. I have this independent source, this one, plus minus 18 volt. Now, how to determine the value of this one? To determine the value of this one, I will take 0.225 multiplied by 4. It's going to be 1 Vx. I will have Vx here. Vx here. Now, I have this 4. I want to determine the value of Vx. How? Let's see. If we see this one and this one, these two and these two are what? In parallel, because they are connected with the same node. Yeah, we discuss. Are connected with the same node here. We discuss. So I can determine the equivalent of this one. So I'll have 2 multiplied by 2 divided by 2 plus 2 equal 1. Means that if I have two resistors that in parallel with the same value, I just take that value divided by 2, it will be my equivalent. So I have V1, and the voltage of this one and the voltage of this one are same since are in parallel. So my circuit can be reduced to this one, to this case. I'll have plus 18, I'll have plus minus Vx plus minus Vx. I'll have Vx in. My circuit was here. I have this plus minus 18. Now, this one is 1, the equivalent of these 2 and 2 with Vx, some Vx. Why? Because the Vx of this one is the same as this one, is the same as the volt equivalent of this one. And here I have 4. So here I will have 3 ampere. Now, how can I do again? I can directly use one one of the methods that we learned before. One of the methods that we learned before, either use mesh or use node analysis, any. If we see here, we will see that I will have, in this case, I will have, if let's choose one, which one are we going to use? Let's say we are using mesh. I will have here, and I'll have here. Here it is I1, here I2. So directly I know that I2 equal 3 ampere, because I2 is this current, same direction with this current. Now we have to use mesh analysis in this one. When we use mesh analysis in this one, you will get I1. When you get I1, here, you will directly determine the value of Vx. Here, let's use this. I can have this resistor mean that 1 I1 minus I2, even I2 is 3 plus 4, therefore it is only 4I2 because there is no other mesh, other loop, plus here I will have Vx, and Vx equal what? Equal this one. Vx equal 1 multiplied by I1 minus I2. Here is going to be plus 18 equals 0. Why Vx? When we come Vx, we have to see in the circuit. Vx is this one. We understand how it comes this one with the 1 from here. Now Vx equal this one, which equal what? Vx is going to be the 1, the resistance, multiplied by the currents. Which currents? I1, since I am mesh 1, I1 minus I2. I1 minus I2. That's the currents across this resistor. How? Because it's come from Castle. This I1 is coming this side, because you see this one here is entering, and that this one is current flow in this one. When you use Castle, you will determine that this current will be I1 minus this one. So now you have this one, you have a value of I2, replace it, you will determine the value of I1. When you get the value of I1, it will be easier to determine the value of Vx, because Vx is going to be equal 1 multiplied by I1 minus I2. That's the value of Vx. The value of Vx here. So mean that when we use source of transformation, we have our network, our circuit, we can use source of transformation. By the end, you will see that to solve the question, to determine, let's say for example, Vx or the currents, you have to use another method, maybe mesh analysis or node analysis. But the beginning, you will use the source of transformation to reduce the circuit. So thank you for watching. In this video, next video, we discuss about another topic, which it is the Thevenin